Hi students, this is a review. Many of you have reached out about some confusion on the conservation of momentum quiz. So I decided to pull some of those questions that were commonly missed and create a review for it. So thanks for watching, and hopefully this will address some of your questions. The first question that was commonly missed states that the final momentum after an inelastic collision is 10.0 kilometers meters per second. The first object involved in the collision had a momentum of 8.00 kilograms meters per second, and the second had a mass of 1.50 kilograms. What is the velocity of the second object? So the first thing that you're going to do is plug in what you know in the formula down here. So we have an object A and an object B, and since it's inelastic, we know that afterwards they're going to stick together, so this is why we're using this formula. And it says the first object had a momentum of 8.0 kilogram meters per second. So we have 8 in here plus 1.5 times the velocity equals 10, because we know that the momentum is equal to mass times velocity. So instead of plugging in what you have here, momentum can be substituted down on this side of the equation because we know that this is the formula for momentum. So then we plug in what we know and we solve for V. So after we solve for V, as you can see, the steps are down over here. You should get 1.33 meters per second. Here is a momentum concept multiple choice question that was missed. So I wanted to point out these two major concepts. It says, in an explosion is when one object breaks into multiple parts. Since an inelastic collision occurs when multiple parts collide and stick, the explosion can be considered the opposite of an inelastic collision. Momentum is always conserved, but there are external forces, so energy is not always conserved. Remember that doesn't mean energy is destroyed, but it is transformed into another form. An example would be it's transformed to heat from friction. It is just lost in the collision or the explosion. Here is another question that is commonly missed. It states a rock with an initial momentum of 3.00 kilogram meters per second breaks into two parts. The first has a momentum of negative 2.00 kilograms meters per second. What must be the momentum of the second? All right. So again, remember the momentum formula here is mass times velocity. So you could always solve the momentum if it's given momentum in anywhere where it's mass times velocity in this formula. So we plug in what we know. So the momentum of the initial rock is 3.00 kilograms. That's where this 3 comes in. And we can again do this because this is basically mass times velocity, which equals momentum. And then breaks into two parts, so we know that the first momentum right here, again, you can sub these in for P, is negative 2. Remember, don't forget the negative side. This is what a lot of y'all missed right here. Plus the momentum of object B, so that's what we're solving for, is this momentum. So we plug into the calculator and we should get 0.005 kilograms meters per second. A 65.0 kilogram astronaut throws a 5.00 kilogram oxygen tank with a velocity of negative 25.0 meters per second. What is the astronaut's velocity if he started at rest? All right, so the first thing you want to consider is that the astronaut and the oxygen tank were together before the explosion. So this is going to be considered an explosion. That's where we get this formula from. So then we plug in what we know. Since the astronaut is at rest, because it states here, we know that the initial side over here is going to be 0 because of this velocity, so it doesn't matter what the mass is, it's going to be 0. So that's where the 0 is coming from. And then we're going to plug in what we know. So the object A, which would be the oxygen tank in this situation, would be 5 for the mass times the velocity, which is negative 25. Don't forget the negative, it's important. Plus 65, which is the mass of the astronaut, but we don't know the velocity after the explosion or when the objects came apart. Again, this is all equaling 0. So we plug into our calculator and solve for V, and you should get 1.92 meters per second. A rock is flying through the air with a momentum of 75.0 kilogram meters per second. It breaks into two pieces. The first piece has a mass of 3.50 kilogram, and the second has a momentum of 92.0 kilograms meters per second. What is the velocity of the first rock? So again, remember that the momentum formula is mass times velocity. So we're going to plug in what we know. So the momentum of the rock initially, so this would be this entire side, mass times velocity, will be 75 kilogram meters per second. And you're going to add that to, it breaks apart. The first piece has a mass of 3.5 and the second has a momentum. So a momentum again can replace an entire mass times velocity. So you have 92.0. And then add what you don't know, which is the velocity. So, but you do know the mass of 3.5 times the velocity. I don't know why it does that. Sorry, guys. So we're going to solve for the velocity, and if you plug into your calculator, you should get negative 4.86 meters per second. And the negative is important because it's showing the direction which is going to be left or slowing down. All right, another concept question that was missed states that what makes a perfectly elastic collision? So a perfectly elastic collision involves objects moving apart after the collision and the conservation of both momentum and kinetic energy. So remember that about the momentum and the kinetic energy. And you should have solved this relationship in your virtual lab for this unit. The next one states two objects with the momentum values of negative 50.0 kilogram meters per second and 75.0 kilogram meter per second collide elastically. After the collision for the first object has the momentum of 40.0 kilograms meter per second. What is the momentum of the second? So another way to write those other formulas again is just using the momentum. So the momentum, initial momentum of object A, that's what this is, the initial momentum of object B equals the final momentum of object A and the final momentum of object B. So we plug in what we know. So we have momentums of negative 50 and 75, and they're going to collide, and afterwards one of the objects have a momentum of 40. And so we are trying to find the momentum. Remember, the conservation momentum states that there's not going to be any loss. So basically, you solve this simple algebraic equation, and you should get the momentum of object B is negative 15.0 kilograms meters per second. Two balls collide. Ball A has a momentum of 7.00 kilogram meters per second, and ball B has a momentum of negative 4.00 kilometers per second. After the collision, ball B has a momentum of 8.00 kilograms meter per second. What is the velocity of ball A if it has a mass of 2.00 kilograms? Again, we're going to use these formulas. Another substitution from the formulas that we've been talking about all unit. And then just plug in what we know. So we have the momentum at 7 plus negative 4, which is the momentum of the second object, equals, now since it's given us a mass, but we don't know the velocity, you substitute 2.0, and then we're solving for V, plus 8, because that's giving us the momentum. And if we plug it into our calculator, we should get negative 2.5 meters per second. All right, and this is the last problem I'm going to cover. It gives you a graph type, and it says both momentum and kinetic energy are conserved in a perfectly elastic collision. We talked about this concept earlier. So the kinetic energy before the collision must be equal to the kinetic energy after. So we plug in the kinetic energy of A initially plus the kinetic energy of object B, and which should equal the after kinetic energy plus of the two objects. So we plug it into our calculator for what we know. The initial object of A, which is what we don't know up here, plus B, which is 0.75, and I'm only getting these numbers from the graph, and equals 6.22 plus 0.03. And again, I'm getting this from the graph. We plug in our calculator and we should get 5.50 joules, and it's in the positive initiation. Alright, so that is it for the quiz review. I hope you take advantage of this before taking the test. Please let me know if you have any questions after you review this.